You ever just stop and think like, whoa, it's me in here, living this whole experience?
Uh-huh.
That's what we're tackling today, consciousness.
The big one.
You guys gave us a ton to work with. Philosophy, science, the whole shebang.
It's a question that has fascinated people, well, probably as long as there have been people.
Yeah,
And for good reason, it gets right to the heart of what it means to be human.
totally. Like, we can't escape being conscious, right? But explaining it is a whole other story.
Exactly. A lot of traditions throughout history have thought about the soul as being the seed of consciousness, like this kind of intangible essence that goes beyond just our physical bodies.
Oh yeah, like the ancient Egyptians, they had all those elaborate beliefs about what happened to the soul after death.
Right, and then you've got the concept of Atman in Hinduism too. It seems like almost every culture has wrestled with this idea that some part of us might outlive our physical selves.
So where does that leave, like, the actual brain in all of this?
Well, that's where philosophy comes in, right? Philosophers have been debating for centuries whether consciousness is totally separate from the body, which they call dualism, or whether it's something produced by the physical processes in the brain, which is materialism.
So dualism is like, is it like a puppeteer controlling a puppet? The puppet's our body, but the puppeteer is somewhere else.
That's a great analogy. And then on the other side, you've got materialism, which would say, nope, there is no puppeteer. The puppet's movements, which are like our thoughts and feelings, are purely because of how it's built. All the strings, the wood in our case would be the brain.
Okay, so this debate between the soul and the brain has been going on forever, and even with all the science we have now, we still don't have a clear winner.
Exactly. And that leads us to what's often called the hard problem of consciousness.
The hard problem. Okay, I'm intrigued.
So think of it this way. We've gotten incredibly good at understanding the brain, like we can map out its different parts, see which parts are active when you do different things.
Right. We've got some fancy brain scans these days.
They do. But explaining how those physical processes, the electricity zipping between neurons, actually create that feeling of being you. How it makes us feel happiness, sadness, or even just see the color blue. That's a whole other thing. We haven't cracked that code.
So it's like we can see all the instruments in an orchestra, we can see them being played, but we don't get how those sounds come together to make the music.
Precisely. And that's what makes consciousness such an intriguing, and maybe for some people, frustrating mystery.
Okay, so pinning down consciousness is like, I don't know, herding cats.
Something like that.
But that hasn't stopped scientists from trying, right? I mean, it's pretty amazing how they're even starting to study something so slippery.
It really is. Philosophy's been wrestling with consciousness for ages, but neuroscience, that's giving us a whole new set of tools to explore it. We're kind of getting a peek behind the curtain of the brain.
So where do you even begin? Is there like a consciousness button in the brain they're looking for?
Wouldn't that be nice? No, there's no single spot like that. One thing they're doing is looking for what are called neural correlates of consciousness, or NCCs for short.
NCCs, huh? Sounds kind of secretive, like something out of a spy movie.
Well, they're not that secret anymore. Basically, NCCs are specific patterns of brain activity that consistently show up when someone's conscious.
Patterns, okay.
Yeah, like imagine trying to figure out what's happening in a city just by watching the lights turn on and off from above. Some places are bright, some are dark. You can get a sense of where the action is. NCCs are kind of like those bright spots, the areas that light up when someone's aware.
So instead of one big switch, it's more like a specific pattern that says consciousness is happening here.
Exactly. And it's interesting, some brain areas keep popping up as really important, like the cerebral cortex, especially the front part, the prefrontal cortex, which handles planning and complex thought. That seems to be a key player.
The prefrontal cortex. Making plans, having thoughts, sounds about right.
And then you've got the thalamus, which is like a relay station, taking in sensory information and sending it to other parts of the brain.
Okay, so we're finding the neighborhoods where consciousness might be hanging out. But how do we know those areas are about the experience of consciousness, not just like passing along data? How do we get from brain activity to me being in here?
That is the million-dollar question. And that's where some really wild research comes in, especially the stuff with split brain patients.
Split brain? Okay, that sounds kind of intense.
It sounds scarier than it is. Basically, these were patients who had their corpus callosum severed. That's the bundle of fibers connecting the two halves of the brain. It was done to treat severe epilepsy.
So each half of their brain was doing its own thing.
In a way, yeah. And what researchers found back in the 60s and 70s was mind-blowing. Imagine showing an image to just the left visual field, which the right side of the brain processes. Normally, that info would shoot over to the left side for language.
But with the connection cut, that couldn't happen.
Right. And at first, the patients would say, I don't see anything. But T, get this. If you ask them to draw what they saw, their left hand, controlled by that right hemisphere, could do it.
Well, wait. One part of their brain saw the image, the other didn't. That's like having two minds in one head.
This is about as close as we get. And it got even wilder. Like each hemisphere could have different preferences, make different choices.
Okay, now you're just messing with me. This whole one-self thing is starting to feel shaky.
That's why the split brain research is so huge. It challenges how we think about being a single conscious person. Maybe consciousness isn't this one big thing, but something that can be divided, even spread out across different parts of the brain.
Mind blown. So if one brain can have these split experiences, what does that even tell us about consciousness itself? It's like our brains are capable of way more than we realize.
Absolutely. And this is just scratching the surface. There's also this really cool phenomenon called binocular rivalry.
Binocular rivalry. Sounds like my eyes are about to have a duel.
Haha. It's kind of like that. So imagine looking through a special device where each eye gets shown a totally different image.
Like instead of those old 3D glasses making one image pop, each eye gets its own thing going on.
Exactly. Now, instead of your brain merging the images like it usually does, it gets confused. It flips back and forth between seeing one or the other. Like your conscious perception is playing tug of war.
Wait a minute, I think I've felt that before. With those optical illusions where it's like a vase but also two faces, it keeps switching.
You got it. That's binocular rivalry in action. And by studying which brain areas are active during each flip, researchers can track the neural activity that goes with those specific experiences.
So it's like watching the brain change channels in real time, flipping between what we're consciously aware of.
Perfectly put. And all of these findings, the NCCs, split brain stuff, binocular rivalry, they're all pieces of the puzzle, right? They give us clues about how brain activity and conscious experience are connected.
Okay, so we've got all these fascinating clues from brain research, specific areas lighting up, different sides of the brain acting like independent agents, perceptions switching back and forth. It's a lot to take in.
It really is. And that's where theories of consciousness come in, right?
Yeah.
It's like they're trying to build a framework, trying to make sense of all these clues, trying to explain how we get you out of all this brain stuff.
So we're moving from the what's happening to the what does it all mean?
Exactly. And there are a few big contenders in the theory department, trying to explain this whole consciousness thing. One that comes up a lot is the global workspace theory, or GWT.
Global workspace. It sounds kind of, official, like a big meeting, but for your whole brain.
I like that. Imagine your brain's this bustling city, okay? Lots of different areas, each one with its own job to handle sensory information, some control movements. Some are all about memories. That's your unconscious chugging along in the background.
Got it. Lots going on behind the scenes.
Right. But when something needs everyone's attention, like it's super important for the whole brain to know about it, that's when it gets up on the big screen, the global workspace.
So it's like a newsflash going out to the whole city.
Exactly. That newsflash is now available for all sorts of higher level stuff, thinking about it, making decisions, sharing it with others. It's not stuck in its little compartment anymore.
Okay, so with GWT, consciousness is like this spotlight that shines on information everyone needs to know about. What about that other theory, the integrated information theory? That one seems to be everywhere too.
Yes, IIT. That one's all about how information is structured and shared within the brain. It's getting into the nitty-gritty of how it all works.
Okay, before we get too deep in the weeds, can you give me the simplified version for those of us who aren't neuroscientists?
Sure. So picture a network of roads connecting different cities. If you only have a few basic roads, things aren't moving efficiently, right? Traffic jams, delays, all that fun stuff. But a complex network with highways and interconnections, everything flows smoothly. Information, goods, people, they can get where they need to go. IIT says that the more interconnected a system is, like those highways, the more conscious it is.
So it's not just about how much brain activity is going on, but how well those different parts are actually talking to each other.
Exactly. A brain going haywire with random activity, that's not necessarily conscious, according to IIT. It's about the connections, the flow of information between all those specialized areas.
So with GWT, it's about making information globally available, and with IIT, it's about how integrated it all is. Two different angles on this huge question. But do any of these theories fully explain it, like the hard problem of consciousness?
That's the thing, we're not there yet. Each theory has its strengths, its weaknesses, and neuroscientists are still debating which is the most accurate or if there's even one single answer. But what's cool is that they're pushing us to think differently about consciousness. We're looking beyond individual neurons firing to see the brain as this crazy, complex, interconnected system.
So instead of getting lost in the details of every little thing happening, we're zooming out to appreciate the whole picture.
Exactly. And that's what makes this such an exciting field. We're getting closer to really understanding what makes us self-aware. There's a long way to go, don't get me wrong, but each new discovery, each theory gets us one step closer.
It's definitely a journey worth taking. And for all of you listening, if you're as fascinated by this stuff as we are, we'll have some more resources linked in the show notes. Trust me, once you start going down this consciousness rabbit hole, you'll never look at your own Eunice the same way again. And on that note, this has been a mind-bending deep dive, and we'll catch you on the next one.